Okay, the next part is about looking at some open source frameworks for linear algebra. And I think there's some very interesting packages here. First up, I like this one. There's something called the sparse matrix collection. It's a museum, if you will, for different types of sparse matrices. So if you really, really, really need to get hundreds or thousands of different kinds of sparse matrices, here's a great way to go about it. And you know, it's really fun to look at. They've got visualizations. I think these are based on MATLAB. But they've got visualizations for every different matrix, and they show some of the code of how they're doing that. And I can go ahead and follow this link because I think it's really worth taking a look at. This is done at University of Florida, and it's curated by Tim Davis and Yifan Hu from Yahoo Labs. Tim Davis is a professor at University of Florida, and if you're using linear algebra packages in R or SAS or MATLAB, basically he wrote them. And you know, a lot of other really high-end uses of linear algebra, like how the images in Google Street View get stitched together, he wrote those too. I saw a lecture by Tim Davis at Stanford last year, you know, and for a math lecture, it was standing room only in an auditorium. Really, really amazing person. But I recommend taking a look through this matrix collection because there's some pretty cool stuff here. Look at these things. They look like, you know, some sort of sea creature from an alien planet. And you can just, you know, navigate around and click on a lot of these. Anyway, cool stuff. If you ever really, really need to be getting a lot of sparse matrices, that's a great place. It has a very practical purpose in the sense of if you have to evaluate new machine learning algorithms, you know, here's your QA, your test vectors, if you will. Another point of open source here that's very useful is something called tall and skinny. So, you know, when we talk about matrices, we talk about square matrices. You can perhaps find the inverse of a square matrix. When you're working with real-world data, though, it's probably not a square matrix. If you're talking about, for instance, log files, and you've got, you know, hundreds of millions of entries, you've got a lot of customers, and you've got log files collected over a long period of time, think about this. You might have only, I don't know, 50 points or 100 points or something per log entry. Not that many. But then you've got, you know, like 100 million rows. So, you know, maybe you've got 50 columns, 100 million rows. It ends up being a very tall and skinny kind of matrix. So if you want to take and do some matrix math on something that's like tall and skinny, that's a real-world problem. It's not going to work very well. However, what you can do is to take and cut the tall and skinny matrix into chunks and process it in a certain kind of transformation. QR factorization is one example of this. Cut it into chunks, and then it has some nice properties. Remember, going back to what we were talking about in abstract algebra before, the chunks can be reassembled at the end simply by just appending them together. No post-processing necessary. So we can handle matrices, sparse matrices that might have, again, hundreds of millions of elements or billions of elements. We can handle those pretty effectively on top of Apache Hadoop. And here's a great package for it. This is done by Austin Benson, now at Stanford, David Gleich at Purdue, James Demmel, I believe, is at Berkeley. They had a paper about this that's a pretty interesting read. But the GitHub code for this is Austin has, and it's some Hadoop streaming in Python. It's a really good way of being able to do QR factorization, and there's some other kinds of factorization as well. So they've got some examples here if you want to try it. Works pretty well. Got to see them presenting some lectures about it. Now, drilling down a bit, David Gleich, one of the authors of that TSQR package, I highly recommend. He's got a lot of resources online, but in particular off of SlideShare and off his homepage. He's at Purdue University, and if you look under presentations, okay, he's got like 44 presentations there on SlideShare. A lot of really great lectures on what you can do with matrices for common types of large-scale business problems with data. You know, here he's talking about QR factorization and how to do that on MapReduce, how to use it to build recommender systems, for instance. Pretty interesting stuff. Now, as far as some textbooks to recommend, I mentioned about Gilbert Strang. There's Introduction to Linear Algebra. That's a good one. Definitely recommend. Online, there's a free book off of Number Theory Web by Keith Matthews. It's called Elementary Linear Algebra. Definitely recommend that. And there's another book I'll be referencing a little bit later by Norman Biggs. It's called Algebraic Graph Theory.